Hello and officially welcome to this webinar. We're truly excited today to talk about a very interesting topic, which is overcoming calibration challenges in GxP. Calibration is something we've worked a lot with or
Very much
is part
so.
of our core business. And we've also been very fortunate that a lot of customers have shared their experiences from audits or from internal to external audits as to what some of the challenges were, and that's part of what we're going to go through today. First of all, so nice to see so many recurring faces as well. Hello, David. It's nice to see. I saw there was also a message about sunny England. If it's anything like it is in Denmark right now, I don't believe you because it's terrible weather here at least. But as always, if you have any questions or comments along the way, just write them in the chat on your right-hand side of the screen, and we'll try to answer as well as we can. But today's topic, we're just without further ado, just going into it. Overcoming calibration challenges. We'll present some of the experiences that we've gotten through our customers, and we've tried to gather some of the consideration and best practices that you can do to overcome some of those challenges. But first of all, who are we?
Yeah.
Why are we even here today? Why do we talk about this topic? I have with me Anya, who's
Yeah.
been with us for a very long time, whose daily job it is to be a QA/QC lead,
Mm,
and also had a lot of experience working with ISO 17025 and
I sure do. Both
working with
the calibrating and looking at the calibration certificates and auditing into it. So I have
yeah.
a few words to say about that.
Absolutely. Yeah, absolutely. My name is Jacob Conradsen, and I'm the Chief Quality Officer here at GxP. So my daily work is to work with our clients in terms of helping them uh, getting through their audits, but also working with our internal quality here. Um, just a little bit about GxP and who we are. At the core of our business is being audit ready, and we help our customers being audit ready by allowing environmental monitoring. So we monitor temperature, humidity, CO2, differential pressure, and a lot more. And we do this through a web platform as well as a calibration service. So with our product, you'll get a data logger and get a yearly calibration as well as monitoring. And we also do thermal validation. So we deal a lot with everything surrounding being audit ready in a thermal compliance setting. Um, but the topic of today, first of all, we're going to start off by identifying what is a calibration, getting the same terminology in place so that we speak about the same things.
That's a good starting point.
That's a very good starting point, speaking the same language. Then we're going to talk a bit about calibration requirements, because that's one of the key pitfalls we see when working towards getting ready for your audits in terms of thermal compliance. And then lastly, we're going to share a bit of our audit readiness advice, some of the pitfalls we see, what are some of the considerations you should have in place when getting audited. I think it's important to mention that it's not about being audit ready, it's about having a high level of quality. But I think some of the processes and some of the considerations that we'll go through today are all about enforcing a continuous improvement and enforcing and helping a high level of quality by having a really good overview of your processes. Where do these requirements come from, and how do you live them?
So by staying ready is
By
what you're
staying
saying.
ready, yeah, being ready constantly. Um, but without further ado, I think we're just going to jump right into what is a calibration. I think there's a lot of understanding of what a calibration is in general, but it's always good to speak the same language. So we come from a background where we work a lot with calibration as an activity that we do for our clients. But some people come from a background in which it's more of a compliance check. But I think it's really important to understand this pyramid of traceability. So what you'll often find in requirements and guidelines is that you need to ensure traceability to international standards. So what does that actually mean? Technically, in the end, it means that whenever we have a measurement, we can always trace that measurement back to the system of units, the SI units. And those are the internationally recognized units for a measure. So that's everything from the meter, the kilogram, the Kelvin, which we're going to talk more about today. And those are often distributed, the traceability of those, down through what we call NMIs, or National Meteorological Institutes. So in most countries, you have one, some you have several national metrology institutes, which are the best to calibrate a certain parameter, that be at the kilogram, the second, or the Kelvin, as in temperature that we're going to talk about today. And then through accredited calibration laboratories, they will get their equipment or their references calibrated at the NMIs, and then they will calibrate equipment which is used at the facility and then down to the goods and products. So it's really through an unbroken chain of calibrations up all the way to the realization of the SI units that we have traceability to international standards. I've often found it funny that it's often referred to as traceability to international standards, but there are only one standard for temperature, and that's the Kelvin that we like to correlate to the Celsius and the Fahrenheit. But often for these measurement parameters, there's actually one standard. And when you say international standards, it's the SI unit, and often you will say traceable to national standards. And when we say traceable to national standards, we mean the local NMI. In some countries, there are more NMI, so you have a bit of choice of freedom. But often, as a pharma company or a GxP company, what you'll have is that you will go to an accredited calibration laboratory. So you don't deal directly with the NMIs, you do it through the accredited calibration laboratory.
So how would you know that you're using the right accredited calibration laboratory?
That's actually a really good question. So as we'll also dive a bit deeper into later on, what there's actually only one ISO standard for accredited calibration laboratories in the world, and that's ISO 17025. And those are being accredited by independent third parties. Again, in most countries, you have one, sometimes more accreditation bodies, which will ensure that a calibration laboratory has the right level of quality control and the right level of technical expertise to perform the calibration as needed. So it's what they do is also to ensure that they have, or we in this case as well, have an unbroken chain of calibrations up until the NMI. A good question, yeah. Again, don't hesitate to put in your questions along the way. So bottom line, I think one thing that's very important to understand is that the whole point of ensuring traceability is that we measure the same. I think if, as you see in this small depiction here, if two people are measuring the storage conditions of a product and they're measuring two different values, we have an issue, right? Back in, I think the story goes that back in medieval days, the first metrological standard was a cubit. And if you're wondering what a cubit is, that was the length of the pharaoh's lower arm until his fingers, and a royal cubit was with the four fingers as well. And that standard was actually used to build the pyramids by. And there was actually a death penalty if you didn't calibrate your measuring stick once a month. So luckily that's not where we are today.
Oh, it's a bit out of scope for today.
A bit out of scope today. I don't think there are many countries left with a death penalty for not calibrating. But the importance is really high. We need to ensure that we have the same system for measuring. Otherwise, we don't have traceability of our products, of our processes, and that means we can't ensure product safety. So for us at least, and I can speak for myself, this is something that's truly important. We're trying to transfer this traceability from the calibration, the international system of units, down to the individual product. The same goes for the measurement of mass. If you don't know how much of a particular API there's in the product, you don't know the safety of the product.
But of course, it doesn't have to measure exactly the same, but you'll get into that later. I believe.
Uncertainty is a large part of it. But so roughly speaking, what is a calibration actually? Well, in practical terms, we do compare a sensor to be calibrated, sometimes called the DUT, the device under test, or some call it DUC, device under calibration, against a reference sensor in a controlled environment. So I don't think this would go for an accredited setup, but it explains nicely what we're talking about. So the calibration laboratory would have a reference calibrated to a very high degree of accuracy and precision, and then use those measurements to compare with the device that we're actually trying to calibrate. And you do this in a controlled environment so that you know what the uncertainties are. And often we see in this picture, liquid is a really good calibration medium because it's very homogeneous, it's very stable. So we have a good comparison of the reference and the sensor to be calibrated. Then we compare those results, And we often compare those results with different temperatures. Now, if we're talking temperature calibration today. So what you do is that you compare at different points, and we'll go into the importance of having several different calibration points. And what you'll obtain is a calibration result. So a calibration result shows how different the reference and the device under calibration are. So in this example, 0.05 degrees Celsius off. So that means if you're using this device under calibration, it will show 0.05 degrees off. So it will measure a little bit more than what the reference does. But the second part is just as important, the uncertainty. So how precise is this comparison? So in this example, it will be plus minus 0.16 degrees. And what does that mean? That means that with 95% certainty, the result will lay somewhere between plus 0.21 degrees and minus 0.11 degrees. There's always going to be uncertainty when we talk about calibration. We can never be absolutely sure about the result. And how to choose that calibration uncertainty and the criteria for when we accept or reject a calibration for a process, we're going to talk a lot more about. But the key thing here to remember is that every calibration result must have a error of indication or a calibration error. It can have a lot of different names and an uncertainty attached to it. If it is not a calibration result if it does not have both. So another part about calibration that we briefly discussed here is accredited versus traceable calibration. There's often a price difference between having accredited and traceable calibrations, but I think it's really important to mention that a traceable calibration is not necessarily worse than accredited calibration. What you do get, though, with an accredited calibration is that, first of all, there's a third-party assessment. When a company has an accreditation, an existing accreditation that has not expired, they have been assessed by an independent third party that has been appointed by that country's government. So it's not just any company that can go out and say, now we accredit companies against 17025. It's much more regulated than, let's say, 27001 or 9001. With a traceable calibration, that you will have to trust that calibration laboratories' practices and how they manage their quality. Second is that the QMS processes are really rigorously defined in ISO 17025, just with like any other quality standard. Whereas traceable calibration can be performed, I say can, because it can be performed without a QMS or a quality processes in place. It doesn't necessarily have to be, but it's just something to be aware about.
So what is a good example of a quality process that's really bringing some value to the ISO accreditation?
I would say it's twofold. A really good question. So it's twofold. One thing is that when you get accredited, there's both a lead assessor who will take care of all of the quality related, that you have a quality management system in place and that it's effective, but you also have a technical assessor. So they will bring someone in who knows something about the area of calibration or your calibration scope, and they will ensure that all your calculations are correct and that they are reasonable, that the uncertainties that you state on your certificate are correct. So you basically get this third-party assessment. But another thing is like the requirement to inform a customer if something has gone wrong with the calibration, for example. There's a lot of different things. And again, a calibration laboratory without an accreditation can be just as good or better than an accredited one. You just don't have that assurance. And that goes down to the third point, which is supplier review. When you have an accredited calibration laboratory, you have already paid the price for an independent third party to do the assessment. Whereas if you have a traceable calibration laboratory or a laboratory doing a traceable calibration, you would have to have both the knowledge to actually assess a calibration laboratory and also the effort in terms of actually going out and auditing. What we're seeing a lot is that in terms of the calibration alone, that when we have our ISO 17025 accreditation, that eliminates a lot of the need of having to audit us as a supplier. And then, as the last point, GxP requirements. There is a lot of there's actually very few places or very special situations in which you need to have accredited calibration laboratories performing your calibration. That's not the underlying requirement. The requirement is that it needs to be traceable to international standard, and then you need to assess the competencies of your supplier, and that's often tied to the laboratory actually being accredited. So whilst it not directly mentioned that it have to be accredited, often we see customers using it as a quick path to ensuring that all of the GxP requirements have been fulfilled.
So if you use a traceable calibration option and you actually audit rigorously into your suppliers, that would be okay,
That's sufficient, yes.
and you would be GxP compliant as well.
Yeah, it's totally viable to be GxP compliant with using a traceable calibration. Yeah, we just need to ensure that all of the items in ISO 17 or 25 have been fulfilled, and that can be a bit of a hassle. But both are viable solutions. I think we're just going to have, just to get you audience involved a little bit, I would love to start a small poll here as to what your biggest calibration headache is today. And while we have that rolling on the screen, we'll come back to it. Okay, there's actually a question here from Melanie. Traceable calibration meaning NIST? Really good question. We often get that question. So NIST is, as far as I remember, an NMI, or at least often a accredited calibration. So what we often see in the US is that our customers require a NIST traceable certificate. That is often performed at an accredited laboratory. NIST is just your local NMI, or one of them. There's actually more. But it basically just means that it has been performed, traceable to the NMI, and that the calibration laboratory is accredited. So it transfers to the same. So just to get a bit of reference here, in Europe, there is a collaboration between all of the different accreditation bodies called ILAC, ILAC, and those have a mutual recognition agreement with, amongst others, the US and NIST and A2LA. So there's actually a common recognition agreement of calibration certificates and accreditations across Europe, US, and most other parts of the world. So those are pretty much the same, or they are in a regulatory setting the same, whether they are NIST traceable. That's another way of saying accredited calibration, of if they are performed at a accredited calibration laboratory. Harmonized, yes, sorry, harmonized. Thank you very much.
So how do you see this from your calibration certificate?
Well, all of the accreditation bodies will have an accreditation logo that you are only allowed to use if you are an accredited company. And often what you'll have as well is that you will have a calibration number tied to your specific calibration laboratory. So if you don't have that specifically on your certificate, it's most likely not an accredited calibration.
And would you also know that they're part of the multilateral agreement by
Or,
having this?
I mean, you need to ensure that the accreditation body who has accredited the laboratory is also part of the ILAC. But if you're in Europe or in US, you're covered. Thank you very much. So just to give a little bit about the poll that was coming up here, what are the biggest challenges? It seems a lot to be handling certificates and documentation and out of tolerance results. So that's very lucky because we're actually going to talk about that today. So thank you very much. We're just going to move on here. So how do you set your calibration requirements? And there are a lot of different requirements to set, but we've picked out the most important ones as we see it. So first of all, as we've just talked about, should you choose accredited or traceable calibration? I must mention as well, you can often in the same laboratory get both an accredited and a traceable calibration done. But first of all, you should consider, do you have the internal audit competencies? So can you actually go and assess a calibration laboratory with the technical expertise and the audit expertise to actually do this? If no, you might choose an accredited laboratory, and yes, you can go away with a traceable laboratory, you need to have a risk assessment as well. So if you choose to go for a traceable calibration, well, you need to have a risk assessment in place on how do you ensure that the results are compliant. And then lastly, GxP requirements. There are some areas of GxP that do require that you choose a traceable calibration in some specific parts of it.
So what would be an element of the risk assessment to make?
So first of all, I would say the major part of your risk assessment, as we've seen it, is that do you actually have the competencies to assess the technical expertise?
All right.
The technical assessor that assesses us, for example, has decades of experience in temperature calibration at a very, very high level. And do you actually have that insight? Because you don't only need to assess the quality management system and the quality process. You also need to assess the technical expertise of the laboratory. Um, yeah, but moving on, the second requirement you should set is what are your calibration points, and there you need to think about your operational range, and we'll go more into detail why that matters. But you need to assess for the specific process in which you're going to use this equipment, which is going to be calibrated, what is the operational range? So let's say you have a fridge that would typically be between 2 and 8 degrees Celsius. Well, can it go below? I mean, could you have a situation where it could go lower? Could it go down to 0 degrees, for example? And if you have a door opening event, could it go above? You still need to capture the data there. In this stage, just think about it's important to know what are the interesting temperature points or humidity or CO2, whatever it might be, that you're going to experience through this process. Secondly, you always need to choose 3 points, and we'll go way more into detail with this in just a minute. And then lastly, in general, what's your calibration interval? How often do you plan to calibrate? And you need a rationale behind this. And we'll also go into detail with this. The calibration uncertainty and the maximum permissible error. If this seems odd, well, we'll go into it in just a second. So we just have another question here from Sunari. We always have calibration expiry date that has to be done again after a certain deadline by the calibration third party. How do they determine the timeline? What are the parameters in which it is decided? For an equipment has 1 year calibration validity, why not 6 months or 2 years?
Now, this is super interesting because the calibration is actually just a point in time measurement. So how can it have an expiry date?
That's a really good question, and we're actually going to go into detail with this. But a key point here is the calibration laboratory cannot set your calibration interval. You are ultimately responsible for the calibration interval. So yeah, I think we'll leave it at that because we're actually going to go into detail this. But remember, the calibration laboratory cannot decide your calibration interval. You'll sometimes find that they set a very short interval so that they know they have business again in another 6 months rather than a year. They can often help, but yeah, we'll go into detail. So first of all, how should you set your calibration points? The important thing is that you have a operational range, let's say 2 to 8 degrees, but you need to have calibration points that are outside of this range, because what happens if the temperature goes just a little bit outside these points? You'd still want to have your calibration to be valid. And why do you need those calibration points? So this is a very simple illustration of the error of calibration. And often within temperature calibrations, it's very exaggerated in this image, but the error will be parabolic. So it will be a second degree polynomial. It will curve some way. It can curve up, it can curve down. Often it will be very linear, but just for the sake of explanation. Let's say we have an acceptable limit for how much error we're willing to accept in a calibration, and this goes here. Let's say that I choose 2 calibration points at the lower limit and at the upper limit. How do I know that in the middle of this interval, the error is unacceptable? I simply do not know. And that is why you need a third calibration point. That's it. There are many, you can go on and on about the technical reasons why it is such, but it's basically because we know that temperature error tends to form as a second degree polynomial. And in order to catch that, you need 3 calibration points. And that's the reason why. So, Another thing is, as I mentioned, is about calibration uncertainty. So while this might be a little bit confusing, the dot in the center of these whiskers is the calibration error, and the central dotted line is 0 degrees. So let's say the dot was at the center. We believe that it measures 0.0 degrees off. But we almost always have some calibration error. What the whiskers are the calibration uncertainty. So how sure are we in this result? So in the first example here, what we'll have, what we can do is then set what we call an MPE, and an MPE is a maximum permissible error. That's the largest error plus uncertainty that we can accept, and that means that we know that whenever it passes the MPE, the maximum uncertainty and error is within this MPE. A great example is for cold storage. We'd often choose an MPE of 0.5 degrees. And that means that if we have a calibration error of 0.25 degrees and an uncertainty of 0.25 degrees, we're just at the limit. But if this goes outside our maximum permissible error, we cannot guarantee that the instrument measures within the tolerances anymore. So moving on a bit, how should you be ready for an audit then? I think
we have a question here actually about and you moved a bit into it about the risk assessments and so on. We have a calibration could be done every 2 years instead of 1 year, and the answer is yes, it could. Again, it's a point in time measurement, but it's all to do with your process. And if you pull up the picture you have again from before here, that if you have any risk assessment saying that your sensor might drift out of this specification and move towards the one with the little X in the middle here, then it's probably better that you do the calibration every year or maybe even more often.
And we'll deep dive into this trend analysis right here. But yeah, again, the whole point of calibrating, as you mentioned, at points in time, is that we want to make sure we might have a good initial calibration, but what happens after a year, what happens after 2 years, or what happens after 3 years.
And this is also why in-calibrations can be a really good tool. So you can actually make an assessment of what was the impact of the error if it
absolutely
went across the line.
Great questions. Thank you very much. But audit readiness.
Yes, let's talk about audit readiness.
Yeah.
Well, the main part here is transparency in creating confidence that you know your process. So this is where you can show an auditor that you understand why you have certain documentation and that it's all based on requirements and that it's in the end based on what process you've chosen to store or operate your customer or your product under. So this outlines from the beginning to the end that the beginning of this will be having some process and product knowledge. You have to define your process. You have to understand what are you storing and what are the requirements for it. What is the duration of the storage? And understanding the process will also make you question what are the requirements for this? Are they external requirements from certain GxP standards? Are they internal because you're a big company and this is how we do it across the line? So there will be some requirements for how you validate your actual equipment or your facility. Those could be mapping requirements. We're not going to go into detail with these because we are focusing on the calibration for this webinar. So the calibration requirements would be what you focus on for the actual process. And that would also be understanding your calibration schedule. And in the end, you'll reach the calibration certificates, mapping reports for the mapping. As again, we're not going to move into that much. We have a ton of other webinars on the mapping. But that would be the actual documentation that you see.
And so, I guess also just as we've talked about, if you know what your process is based on your products, well, then it's very easy to translate those into calibration requirements. Exactly. You know what your process is, what your desired temperature range is, then you know what your calibration points are, you know how much uncertainty you're allowed to have, and that means you know what your calibration schedule is. Yeah.
And you know exactly what kind of documentation you need as well. So first of all, you need a process description. You need to describe what are you storing and under which conditions and what does it look like. And then you will need to define your calibration requirements. And among other things, there are the things that we actually talked about already. So we have the interval, the calibration interval, and what are the rationales behind it? Is it because we want to make sure that we have the risk area covered. So if your temperature reaches above the interval that you expected storage is, then you need to know that your sensor can measure within these intervals. We have the calibration point rationales that we basically covered now, and then the end calibrations, as we just discussed. That if you want to know exactly how much your sensor drifted within the time of use, whether it's 1 or 2 years, as we discussed, this is what you can do. You can make a in calibration requirement. You can also make a risk assessment saying it's not necessary to know this, and we look at the product we well that we purchased or that we rented, as it would be for us, and look at what the requirements are, what the expected drift are, and expected accuracy of drift. And then in the end, we're moving into each equipment would have a calibration certificate for each sensor that they would have. Yeah. So this would be how you look at your process.
Yeah.
Yeah.
And,
from start to
I
the
think
end.
now I'll be the mean auditor and ask you those questions. So how do I actually, so I guess the first question an auditor might ask, so we're standing here at a fridge. What is this used for?
Yeah. And this is where you need to be completely transparent. You need to understand what is your process actually. So the process would involve, what this is this type of freezer. It's used for, now the example is an intermediate storage, so it's not staying here forever. It's for outgoing products, so it's defined which kind of products you're storing there, and you have a desired range. And of course, the process then moves into the requirements that you need for it. So this is also speaking into, you can answer that, well, here the products are stored for maximum 24 hours, feeding into the fact that it's an intermediate storage and it's not staying there forever.
Yeah. And I guess that also shows the auditor, that's often what we experience, the organizations who have this very well structured, when they can answer what their process is before they start talking about the equipment, they understand actually what their process is. The process is storage, and they know the desired tolerance range. Right?
Yeah. So the process is what we want to achieve in the end. Yeah.
Perfect. So moving on. So what validation and calibration requirements have you set for this fridge or whatever it might be?
Yeah, so calibration requirements actually feeds into the validation as well, because if you do a mapping, you would do it with calibration, calibrated sensors as well, usually. So you need to understand, especially for the mappings, whether you want to have the in calibration, as we discussed before. But the calibration requirements for the continuous monitoring or the continual monitoring that we have in your equipment or your facility would again have to have these different requirements set based on your process again. So this is an answer you could answer to this question if you were audited. For this process, the range is 2 to 8 degrees, as we had before, and therefore we chose these calibration points, so 0, 5, and 10. And why are these the calibration points? Because they cover below the actual range and above the actual range. So this would be clear and good choice of calibration points for this one. And then again, the risk assessments are playing into this. We calibrate yearly due to the risk assessment and GxP requirements. So you understand exactly where the requirements are actually coming from, whether it's internal requirements or it's GxP requirements that you're being audited against. Yeah.
Perfect. Of course, these answers are overly simplified, right?
Yeah.
I think you would get in trouble by just answering this along the way.
Yeah.
But
if you were looking into a facility where you're constantly having some sort of transport, there would be more requirements to look into, of course.
So I guess the question that we see a lot of being asked, so show me the documentation, show me the calibration certificate for this.
Because it's all well to know your process and understand it and show confidence that you understand exactly what is going on here. But if you can't prove that these rationales are backed up by calibration certificates, for example, then it's not going to be of value to an auditor. So auditors like me, myself and I, we love to see some objective evidence that actually backs up what you're showing in your SOPs, for example. So of course, you would show the documentation to answer this question. And then you would also show that the answer here, this equipment is monitored with this logger, and here's a certificate. And you're showing the certificate, and you're also showing that the requirements that you just listed, and you know that where they're coming from, that they're actually checked one-to-one. So if you have a requirement for a certain uncertainty to be calibrated at, you should be able to read that from your certificate. And that also feeds into the fact that you need competent people who can actually read a calibration certificate to be able to have good documentation. So there's both the documentation in itself, and there's the review of the documentation, again, whether it's a mapping report or a calibration certificate in this regard.
So I think also what's really important to take away from this is that what we see working really, really well is that you understand this logical order rather than going directly to the calibration certificate, because yeah, how can you evaluate what's in there? How can you sign off a calibration certificate if you don't know where those requirements come from? And how do you know what those requirements should be if you don't have your process and product knowledge?
So there's a lot of value in understanding the choices that was made and the
exactly. And
baseline for this.
If you can show that to the auditor that that is the approach you took, you didn't start by just getting a certificate and then working your way back up to the requirements and the process. You actually took that logical order. That was the decision.
So you are not fitting the 2 to 8 degrees into a calibration certificate that covers minus 20 to 50.
Yeah, exactly. So we got a question here from Francis. So if we calibrate the high point at 10 degrees, the materials inside the unit is exposed to temperature out of operating range. Is that okay? No, it is not okay. But for excursion specifically, for example, I have yet to see someone storing something in a fridge that did not from time to time experience excursions. But the point here being that if your target range is 2 to 8 degrees and you have an excursion up to 10 degrees, for example, often sometimes higher, then you'd also need to extend your calibration range. Well, you need to show with confidence that the excursion was not more than 10 degrees. And how can you do that if you haven't calibrated it? I hope that makes sense. It's never okay to expose it to more, but when you do have an excursion of temperature, you can calculate the mean kinetic temperature to verify it and so forth. There's a lot of different
we have another question here about which kind of documents that an auditor would like to see. And that can depend on the type of auditor. Some auditors would like to see even down to the raw data and can dig down a rabbit hole and go all the way looking at the training that you received as the calibrator of a certain calibration certificate. But you could also choose to stay on top, stay from the top and look at the procedure first to see, okay, this is what you say you're doing. This is aligning with the GxP requirements we're auditing into. And then you can go from there and move down as we pictured here with the process first, all the way down to the specific documentation.
Yeah. So just to sum up as well, what are the documents? Often we see a process description in which you identify what your process is, and that's often multi-equipment, multi-facility. So let's say you get it in, it's intermediate storage, it gets stored long-term in a fridge, then it gets out intermediate storage, and then it's outgoing. And then you start specifying what should your equipment do. That's part of it as well. Both your fridge, for example, what should that be capable of doing and so forth. And then you end up having the monitoring equipment and your calibration.
There will also be some idea in looking into the allowances. So you might have a facility or an equipment, and you might allow this to go out of temperature, out of range for a certain amount of time, and that should be described as well, and that's also valuable.
Absolutely. There's a lot of great questions. We'll get back to some of them. There's a lot more than we had anticipated, so we'll just move a little bit on and we'll get back to a lot of the questions here exactly. So what are some of the common pitfalls we see and how to avoid them? These are based on our experiences. What do we see out there when talking to customers, when we get audits ourselves and so forth? First of all, it's not having a rationale behind the calibration uncertainty, not necessarily the calibration uncertainty, but the MPE. Remember, the MPE is a global variable that you can set and say, this is the maximum error plus uncertainty we can have for any equipment. Sometimes we see organizations choosing extremely low uncertainties, and that's going to have a very high cost. So as an example, if you're storing something in controlled room temperature, which is a little bit different in the EU than the US, but in the EU at least it's 15 to 25 degrees, you have 10 degrees there, then 0.5 degrees is not going to matter that much. As you can see from the depiction here, whenever we set a process limit, let's say it's 25.00 degrees, we need to subtract the MPE, which would be 24.5 degrees Celsius, because if we had a measurement of 25 degrees, that would actually, with our MP, be outside our operational range. And again, on the other side, choosing too high of an uncertainty can have operational efficiencies. You're going to have a lot of alarms if you choose an uncertainty that's very, very high. Um, Secondly, we have not understanding calibration. We see a lot of findings with customers because calibration has been purchased as an off-the-shelf thing. And it is in most cases, but you need to be able to understand rudimentary what is a calibration, why do we do it, and the whole process that we have been through here. What is your process? What is that set of requirements? And what calibration requirements have you set? And that's the certificate we end up with. Because if we don't know what our requirements are, how can we review a certificate? And or secondly, how do you actually review a certificate? What's on a certificate? The fortunate situation is that ISO 17025 very clearly describes what should be in a certificate. It can be in a lot of different ways, of course, but the minimum amount of information in a certificate is mandated by 17025 in very decisive terms. So you need to have that understanding of what it actually is you're looking for when, and then lastly, what have you ordered? This comes back to setting your calibration requirements. What did you actually order? We see an alarming amount of organization just ordering a calibration, but you can't just order a calibration. You need to order specifically what is it that you've ordered and is that actually what you've gotten? Because you'd also want to show consistency. Year by year, you should often not really change your calibration requirements. It can happen, it's totally fine, but it often leads to misunderstood reviews of calibration.
So I think we experienced a few times is that we have customers purchasing a traceable calibration, and then when they have an auditor visiting, they come back to us and say, "Hey, why do we not have the little stamp in the corner?"
Yes.
So that's a very good example of
Mm.
understanding what a calibration is and what you actually purchased.
Absolutely. And then we had the question earlier, how often should you have your calibration interval? And there are two major parts to this, which is, first of all, equipment drifts. And what does drift mean? It means if you took a sensor and you used it, over time, it's going to show a different result. The calibration error is going to change over time. Sometimes it's for the better, sometimes it's for the worse. We don't know. That's the one thing during what we call normal usage. So if you use it as per the specifications of the equipment, it's going to drift over time. There's not a single piece of there's not a single sensor in the world that does not drift. Simply impossible.
So how would you
I've
see?
yet to see it at least.
How would you read anything about the drift in your calibration
Often it's going to
certificate?
show in the data sheet. You're going to have it, and of course you can't say for that specific sensor what the drift is, because you would have to calibrate it, use it, and then calibrate it. But often the supplier is going to provide a small maximum drift where most of the what the upper and lower limit for drifts are. The second thing is what we call sudden changes. I think that's a very nice way of saying what do you call it? When something slips your hand and you drop something. Those are the most normal occurrences. Temperature sensors today are very, very stable, but if you do give it a large mechanical shock, it's going to drift rapidly at one point in time. More seriously, it is for relative humidity sensors. Relative humidity sensors are often, most types are really prone to chemical compounds, for example, and they're going to show a very large amount of drift. But the whole point here is that we are trying to predict the future. And of course, that's going to be impossible. So let's say this is an example of first year's calibration. Everything is fine. We're within our MPE. Second year, everything is fine, or however interval you like to choose. But at the last point, it's going to go outside. And this is the tendency we're trying to predict. And the change from year to year, of which is often drift, is what sets our calibration interval. I do know that in a lot of places, it has been put into your own system, or it's been put into auditors' mindsets that sensors, temperature sensors, must be calibrated yearly. And that's the case, go with that. But technically, there's no reason why you should not be able to extend it. And sometimes you can do it. Let's say, oh, we've had this equipment for years. It has drifted by so and so much. So we expect to extend the calibration period just a little bit. So there's a good question related to this topic. Have you some experience / samples for drift, for example, with a PT100? I would love to say that PT100s are the same, but they are not. Just like cars, they are very, very different. PT100s can be made, has a very large susceptibility to the production process, and PT100 sensors are also very susceptible to mechanical shock. So it's actually quite funny that often PT100 sensors drift less and less as the years go by. They become more and more valuable because the drift tends to fade out and the drift per year becomes smaller and smaller. It is very, very different. I know that in a lot of forums and a lot of discussions, PT100 sensors are seen as a homogeneous mass of sensors, but they are very, very different. Sorry, but typical drift would be something like 0.05 degrees per year for a typical sensor to be used in a fridge or in a control room temperature, just to give you some idea of the scale of things. Our reference equipment drifts 0.00 or 0.01 degrees per year. It's a very, very stable piece of equipment. But then again, it really depends on how you're using it.
So what happens when you get the result back from in calibration and it's on the last point here? Do you throw everything away right
I'm
away?
glad you asked. Exactly. So one of the things is, well, some of the pitfalls is not being ready for out of tolerance. So what happens if you go out of tolerance? Of course, it's never a nice thing, but it's so important to be prepared. What is your plan? And this is going to be very, very different from different organizations. The sensitivity of products, what you store for how long periods of time, whatever it might be. But in general, what you need to do is to do an impact assessment. So uh, the easiest way to do this is saying, okay, our sensor has drifted 0.1 degrees outside of our tolerance. What would that would mean? Let's say the initial calibration was fine, and then after a year it is 0.1 degrees out of tolerance. The most basic thing and the easiest thing to do is basically saying, let's assume that it was constantly 0.1 degree outside. That's our worst case storage conditions. So what does that mean? Let's say, look at our temperature data and say, let's say all of the temperatures were now 0.1 degree higher than what we thought. What does that have of the impact on the product? In most cases, you're never going to be that close to the alarm limit or your tolerance limit. But let's just say it does. So you can very simply export your data and just add 0.1 degrees if that's your evaluation. Normally, it's way less, but for the sake of experiment,
So would you have to account for the drift set by the supplier for the
well,
sensor?
when we get a calibration results that out of tolerance, we already know what the drift was. We just compare the calibration last with the calibration we have now, and then theoretically it could have gone up and then down back to the point. But in most cases, drift is never going to go up and down. It tends to go in one direction. A good point. And then, of course, who should you notify going forward? And secondly, what are your requirements? You need to have a good way of detecting that you're going out of tolerance. We see a lot of cases where, going back to actually being able to review the certificates, that you don't know what it actually is you're looking for. So you need to ensure that you have good requirements. That also leads you to decision rules. We see a lot of companies in which you don't have specific decision rules for when to accept a certificate or when not to. Some laboratories will write in the MP and whether it has passed or not passed, and some laboratories will just give you results and you'll have to add them up. And again, back to the certificate review. Um, just going a little bit further, and then we'll go through a lot of all the great questions here. The last thing we often see is what we call organizational drift. So let's say on an organizational level, you'd put in a lot of effort in defining your calibration requirements and your calibration schedule, all combined in these calibration requirements. But then we see that individual departments develop their own requirements based on local ideas that they can develop. We see a lot, and that goes back to last month's uh, webinar about organizational harmonization in these requirements. It's very rarely that we see that there's any benefit in having local requirements for your calibration. When you store something in a fridge 2 to 8 degrees cold storage, those are often the same requirements that go throughout your entire cold chain or your organization. So a lot of, and of course, there can be a lot of different risks, there can be a lot of different scenarios, but having a baseline of requirements can often benefit us. I lied. I have just one more slide, then we'll go through all the questions. The last thing is the ISO 17025 trap, as we call it, where you just check the logo. A calibration laboratory can be accredited, but that does not mean they're accredited to calibrate exactly what you're asking for. And that's what we call the scope. The scope of accreditation says this laboratory can calibrate between 0 and 100 degrees. They can still offer a minus 10 degrees calibration, but that will not be accredited. So you need to ensure the scope. Sometimes that's on their website. Sometimes it's on the accreditation body's website. Secondly, you need to check the certification. Often accreditation bodies will not, they will redact the accreditation status, but they don't force you to deliver back the PDF certificates that you store somewhere. So check in the national registry, is this company actually currently accredited? And then lastly, get the certificate. It's such an easy thing to do, but when you get the ISO 17025 certificate or the accreditation certificate, you're way more likely to pass an audit.
But is it easy to learn how to read them?
The certificates or the accreditation certificates are just like 9001 certificates, like 27001 certificates, like all the other. They will have a very clear scope on them. They will have the place in which the physical locations in which they're able to perform these calibrations. Some laboratories can perform in situ calibrations on site, and that will all be on there. I would say, compared to a calibration certificate, it's way easier to read an accreditation certificate. So we have just a few minutes left, but let's just run through some of the great questions. From Melanie here, I'll see the actual parameters, risk-based parameter, and then the parameters of the stability of the product. Exactly, it all depends on the individual products. What we're talking about here is maintaining a controlled state for ensuring that at least your calibration is in order. When you have excursions, there was also the question before about, well, why would I need to have calibration outside my desired operational range? Well, that is because you need to assess when you have excursions, what was the impact of those? And you can use a variety of techniques. You have stability data for the drug, for example. You can also calculate mean kinetic temperature. The USP just came out this year with an updated, very nice note on how to use MKT. It's also part of our product. That's why I know I've read through it a lot. You can calculate the MKT. There's a lot of different ways in order to use the data to assess the impact. But the important thing is here that the measurements you use to assess your impact needs to be calibrated. Otherwise, you can't trust them. In theory, let's say you calibrate to 10 degrees and you have an excursion to 11 degrees. Technically, it's not going to go amok the uncertainty. It's not like it's just going to show you totally bananas data, of course. But in theory, you need to have the calibration interval covering the data that you need to trust. I hope that makes sense. So there's another question here from Renee. If talking about fridge calibration, I assume you mean a complete temperature mapping, 9-point. So only calibration, the temperature sensor of the electronic, I assume, is not enough. Yes, so really great question. There's a difference between mapping, which is sometimes referred to as testing, at least in ISO 17025 definitions, and calibration. When we calibrate something, we get a specific result for a specific sensor. So sometimes you can calibrate the control sensor in a fridge, for example, but that will only tell you whether the indication on the fridge itself is within tolerance or not. When we, as we also showed when Anya went through here, is that you also need to map a fridge, but that's to show that the temperatures are homogeneous and stable and so forth. But for the ongoing monitoring, your sensor needs to be calibrated as well. I hope that answered the question. And then a point from Chris Martin here. In my experience, the authorities in the UK do not like the use of MKT as a temperature measure. Totally agree. That, in my experience, is very, very locally based, whether authorities like the use of MKT or not. I personally believe that a large reason for why authorities don't like MKT is because it has been grossly misused. So if someone wants to look it up, it's USP 1079.2. It's very, very recent. And in there, they also explain that it's basically an advanced average. I hope someone can look it up at some point in time and put in a link, that you can use to assess an excursion, both in terms of how high temperature it was and the duration, whether that has actually had an impact. It has been grossly misused by a lot of organizations, and I think that's some of the reason why it's not really been adapted that well. There are other ways to do it. Ideally, of course, you need to assess the stability data for a drug and whether that has had an impact now. I know that in the US, it's very widely used. Some parts of Europe, it's very widely used. But I hope that with the introduction of the 1079.2, that more organizations will start to use it or use something even more sophisticated. So there's another question here from Yadir. A common finding raised during the GCP audits I performed was related to the confusion between calibration and preventive maintenance verification. What is your experience about calibration compliance in the GCP environment? You raise a really, really important point here, which is the difference between a verification and a calibration. A verification is in large part the same as a calibration, but often you wouldn't compare your calibration error to a known, or you would compare it to a known tolerance, but often you wouldn't add in the uncertainty of calibration. One could argue that they are the same, but they are slightly different. Ongoing verifications are really good at catching between calibrations whether your equipment has experienced some type of failure or whether it has drifted outside of requirements. So let's say during an ongoing verification, you'll see that, well, this seems to have drifted. Let's do a calibration. Maybe that's a whole other point for for a different webinar. But
there are many rabbit holes.
Yeah, there are. Let me see if there were any other questions along the way. Yes, there was the last question here that, as I see it, oh yeah, this one from David. Surely the calibration how it sets a limit, a calibration period to allow for any variability over time, not to make you recalibrate on an annual basis, even though that would seem to be the sensible. I would suggest that recalibration meets the requirement of the regulator in GMP GDP that is normally annual. Again, totally agree. Some authorities and some governmental bodies do have recommendations for how often you should calibrate. If you read through the, and correct me, chat, if I'm wrong here, that the only place in GDP, at least, where it's mentioned how often you should calibrate is for transport loggers. And I don't see any specific requirements for calibration intervals in the GMP or in the pharmacopoeia exactly. There might be some specific areas that I have known. But it all comes down to risk. We've run out of time here. Thank you very much for all the fantastic questions. It's very rare that we get to answer this many questions. I hope you have had a great time. If you wouldn't mind, we'll just do a small outro. And if you could write whether you like the webinar or not, or write us if there are any questions or comments to this. It's much appreciated. Thank you again. This is the community that makes us do these things. These are all the great discussions that we're having, which makes us love doing these. So thank you very much. And we have another webinar next month if you're interested.
Thank you.